This is the second video of Module 6. Recall from video 1 we were working on a healthcare clinic model, and so we had finished using placing the servers that represent each station, and we decided we were going to use sequences to represent the entity flow through the model. And so we went through and implemented that in the model, and we also used entities moving through free space, and that's why we don't see any links between the individual servers. And so we want to pick up here with the second part of the model. The first thing that I want to do is to speed the entities back up. Recall that we slowed them down a little bit just so that we could discuss entities moving through free space. So let's put them back to their default speed of 2 meters per second. And now when you see when we hit run, we can see that the entities are moving much faster through the model. Okay, so now what we need to do is put the individual parameters in. So recall from our queuing model, our static model, the things that we need to put in the model are the arrival rates for the individual patient types and the processing times for the individual stations, because the entity sequences handle the flow of entities and directing entities to the correct place. So let's just go through and put those values in. So let me make the properties box just a little bit bigger so we can see that. The first thing is source 1, which represents our walk-in patients, and walk-in patients that arrive at the rate of 10 per hour. So the inter-arrival time will be 6 minutes. So we have random exponential 6. Lab patients arrive at the rate of 20 per hour. So we say that inter-arrival time will be 3 minutes. X-ray patients arrive at the rate of 5 per hour. So we will have inter-arrival time of, not 0.12, but 12 minutes. MRI patients arrive at the rate of 6 per hour, so an inter-arrival time of 10 minutes. And finally, our EKG patients arrive at the rate of 2 per hour, so that is an inter-arrival time of 30 minutes. So walk-in patients 6 minutes 10 per hour, lab patients 3 minutes 20 per hour, X-ray patients 12 minutes 5 per hour, MRI patients 10 minutes 6 per hour, and finally EKG patients 30 minutes, corresponding to a rate of 2 per hour. Next we'll work on the server processing times, and so we have the processing times and capacities given in our static model, and what we'll do is we just have the mean values, so we'll use symmetric triangular distributions. We focus primarily on exponential distributions to this point, so let's use some triangular distributions for this model. So the registration, there's capacity 1 for the server, and the mean value is 2 minutes. So let's just make this triangular 1, 2, 3. Again, I'm just making up these values because we weren't given any information about the specific distribution, just the mean value. The triage server has capacity 1, and the nominal time is 5 minutes, so capacity 1, and we'll make this one 357. Again, symmetric triangular so that we get the mean we're expecting. The X-ray has capacity 1 and 10 minutes. So capacity 1, and let's do 8, 10, 12 minutes. The MRI has capacity 2, and the nominal time is 18 minutes. So we take the capacity 2, and we'll use triangular. Let's do 14, 18, 22 minutes. The treatment room, there are 2 treatment rooms, or 2 treatment capacity 2 for the treatment server, and the nominal processing time is 10.5. So we go to treatment, make it capacity 2, and let's do 7, 10.5. Let's see, what's that? 2.5, 13 for our symmetric triangular. The lab time there are 4 lab tech clinicians, and the processing time is 10 minutes. So we have capacity 4, and let's do 6, 10, 14 for the distribution. EKG has 1 clinician, and the processing time is 25 minutes. So let's do 20, 25, and 30 for the parameters. And finally, accounting takes 5 minutes, and there are 4 accounting clerks. So there are 4 accounting clerks, and let's say that this is 2, 5, 8. So we have for registration, capacity 1 with a mean of 2 minutes. For triage, we have a capacity 1 with a mean of 5 minutes. For X-ray, we have capacity 1 for a mean of 10 minutes. MRI, capacity 2, mean of 18 minutes. Treatment, capacity 2, mean of 10.5 minutes. Lab, capacity 4 with a mean of 10 minutes. EKG, capacity 1 with a mean of 25 minutes. And finally, accounting, capacity 4 with a mean of 5 minutes. So at this point, we have the sequences defined, we have the arrival rates defined, and we have the service times defined. So we can now run our model and observe what happens. So we can speed it up a little bit and watch. And as usual, we would like to develop some expectation of what we think we're going to see. If we recall back to our static model, all of our servers were stable, so none of the utilizations were 1 or greater, so we don't expect to see any infinite queuing, which that's what it looks like that we see, at least from our initial interactive run. Of course, the step to do the actual verification, what we're going to do is set up an experiment, and we can compare the simulation results that we get to the exact results that we got in our static model. And the results that we looked at for our static model were simply the utilizations of the individual servers. So let's do that. Let's jump back to the project homepage and create a new experiment. And we're going to run our experiment. Let's run for 1,000 hours. And let's have a 500-hour warm-up. And let's run for, I don't know, 20 replications seems like a reasonable amount. And so now we can simply run our model and then come back and look at the results. Okay, so that took a little bit longer than I expected, but I guess we ran for quite a while, 1,000 hours for each replication at 20 replications. So let's go look at the results, and we're going to use the pivot grid. I could easily construct responses, but this time we're going to use the pivot grid because we have quite a few utilizations that we'd like to look at. And so what I'm going to do is I'm going to go ahead and filter my pivot grid so that I can just get the values that I'm particularly interested in. So what I want for our verification are the scheduled utilizations, and you can see that we can just extract those quite easily. And so I'm also going to, now that I have the view that I want, I'm going to create a view on server utilizations. And by creating the view, now I can go back and look at the default when I want to look at other views of the data, of the results, and then I can always jump back and just get those values that I'm particularly interested in. So if we compare those to what we expect, let's see if I can figure out a way to get these both on the screen. Doesn't look like I'm going to be able to. Limited screen real estate here, so let's well, anyway, I can just read them off to you. So the accounting, we have an average of 89.9, and our expectation was 89.6, satisfied there. Our EKG is 85.0927, and we expected 83.3. Our lab is 83.7, and we expected 83.3. Our MRI is 90.068, and we expected 90. Our registration is 76.91, and we expected 76.7. Our treatment is 84.6, and we expected 87.5. Our triage is 83.2, and we expected 83.3. And our x-ray is 83.9, and we expected 83.3. So there are two of these that, at least from my read, seem to be a little bit far off, and those were the, let's see, I've forgotten which one they were. So it wasn't accounting and EKG. It was EKG, which we expected to be 83.3 and is 85.5. And registration, which we expected to be, no, registration is fine. MRI is fine. Lab is fine. Treatment, it's treatment. So EKG and treatment seem to be a little off. So let's go see if we can try to figure out whether there is a problem or whether it's just random chance. So let's go back to our model and look at these two processes. And so we have EKG, which we have capacity 1 with an expected time of 25, and treatment, which has capacity 2 with the processing time of 10.5. So first let's look at EKG, and I go and choose my EKG, and I have capacity 1 and random dot triangular 20, 25, 30. So that looks good. I have an expected time of 25 and a capacity of 1. I go look at my EKG patients, and the EKG source is arriving with an exponential with a mean of 30 minutes. So that's 2 per hour. And finally, I go back and look at my look at my sequences, and my EKG sequence appears to be in order: registration, EKG, accounting, and I don't see that I've made any other mistakes with EKG here. So EKG so far looks pretty good. If we look at treatment, what we expect is a capacity 2 and a processing time of 10.5. So we look at treatment, and we have triangular 7, 10.5, 13. And it appears that our problem is right here. I did some bad math. The 7 to 10.5 is 3.5, and 10.5 to 13 is 2.5. So I don't have the symmetric triangular distribution that I thought I did. So I go back and make that 14. And so my new hypothesis now is that it's random chance that the EKG was off a little bit or was not within what I expected, and that's entirely plausible because it has such a low arrival rate. But that we had a problem actually with treatment. So let's reset and rerun our experiment and see if that fixes the situation, at least for the treatment. So the model is now finished running, so we can go back to our pivot grid, which maintains the view that we expected, and we can look at our two suspect values. Treatment, we can see, is now 87.5, and our expectation of treatment was that it was 87.5. So from our current evidence, it looks as though having the incorrect parameters for the triangular distribution fixed that problem, or that was the problem, and we've subsequently fixed it. For EKG, I expect 83.3, and this time I got 82.68. And as I mentioned, it has a pretty high half width because of it's a fairly infrequent. You have fairly few observations of this value, and so this would be within my range of expectation. Now, clearly, we could go back and run for longer or run more replications until we became more convinced if we wanted to, and that's clearly something you should try, but we're not going to do that here on the video. So this example just points out two things. First of all, I didn't stage this. It just sort of happened that I used the wrong value, although I could have staged it, because it turns out that it's a great example of why we want to develop expectation. Had I not developed the expectation, then I wouldn't have had any way to look at the values and realize that there was a potential problem. And so it emphasizes the importance or the need to go through the verification process explicitly. Similarly, it also shows that while some values might look incorrect, as the EKG did, or it looked suspect when we started, it turns out that it's not suspect. It's just the fact that randomness has come into play here, and we have a fairly infrequently occurring event. So to satisfy my own curiosity, I went ahead and ran for longer. I ran for 2,000 hours, so I doubled the run length just to check out this EKG. And so let me see if I can figure out how to get these both on the screen. There we go. We can almost see them. There we go. And so now we can see that EKG is within 83.08, and our expectation is 83.3, and our half width has been reduced from 1 point something to 0.6. And so at this point, I think it's fairly clear that the model behaves exactly as we expect it to do. And so at this point, I would say that we have a completely verified model. To conclude this video, I went back and changed the entity symbols to add animated people, so that instead of the boring triangles, we could see people moving through the system. And so we still don't have any spatial relationship, but we can still see the entities moving through free space. And so what we have done in this model is we've used the free space and for entity movement, and we have also implemented entity sequences to handle the routing between alternatives. In the next video, we will continue looking at sequences, and we will look at how to use a single table for all of the sequences.